Hello? Yes, I think we're live. Okay. Welcome to the second video in a short video series on making asteroids or an asteroid style game in JavaScript using the P5 library. Right, in the first video, what have we established? We've got some asteroids sliding around space, some stars that are not twinkling, had a twinkling fail. And so in this video, which I'm going to try and keep, what's the time? Okay, the time, I'm going to try and keep this under half an hour, maybe 25 minutes. All we want is a triangle ship. I would prefer the ship to be an egg shape, um, and have it rotating. And we need some physics for the ship because it can accelerate as we press the up arrow, and it'll also be screen wrapped. We've already got screen wrapping for the asteroid. So you see as they go off the X axis or off the Y, then they reappear at the opposite end of the screen. And I think actually, have I just spotted a bug? Have we got some weird boundary issues going on? Anyway, I'll ignore this. So we want to get our ship going. So let's get started. And thank you to David with two eyes 000. Good comment. No in-depth explanations from me this time. I'll just comment as I go and do something in the first 12 minutes. So it's been a minute. I think it's just been a minute. Have I done anything yet? I don't know. Right. We need a ship. We need a ship. So we're going to make a ship object. Let's just get our variable ready. My voice is going. That's convenient. So down the bottom is where I create my variable, my objects. We've got a star object, needless. I could have just put the stars into an array, but I made a full-blown object because I wasn't thinking straight. So we've got function ship, and then this ship needs a position, and that's going to be a vector. And we do want the ship not to start at a random place, but in the center of the screen. So the easiest way to do that is width divided by 2, and accordingly height divided by 2. So when we instantiate our ship, it'll appear in the middle of the screen. Then it needs a velocity vector, and that's going to start at 0. We don't want any movement to begin with. Now we want some proper physics, so this is going to be slightly different to the asteroids, in that the asteroids just had a constant velocity. That's all they needed. But the ship, it will need some acceleration. That's going to represent a force. When we want the ship to move, we'll add a force to it. So again, we don't want any acceleration yet. And it's going to need a rotation. This is the scary bit. I'm going to have to make a triangle, which I don't usually do, and then rotate it, and then move it forward according to its rotation. So I need a sine function, a bit of cosine as well. Right, what was I doing? Acceleration. Oh yes, we need an angle. We'll call that theta. Right, and that will equal 0 to begin with. Right, let's draw our ship. Let's get her on screen, and then we'll feel a bit better about ourselves and our lives if we've got that going. So prototype. Render our ship. This is a function, an object's function. So I kind of want it cartoony again. So stroke weight means the thickness of the lines that you're drawing with. And let's go for force. That's pretty weighty. And then the color of the lines. White would help the ship stand out. But I wonder, the actual ship itself would be nice if it were blue. I think blue would be nice. So bright blue. Sorry, no red, no green. A bit of blue. And then maybe to be a bit fancy, let's throw some alpha in there. So the fourth parameter will tell P5 how opaque or transparent you want the fill to be, the color to be. So about halfway. 255 would be completely opaque. 0 would be completely transparent. So 101, just under halfway. So right, now we've got to cut to the chase. Let's draw a triangle. So I believe I believe that's how you spell triangle. I believe you put in 6 parameters. So basically, you're describing where each vertex is going to be. So 3 vertices. So the first vertex is x, y. second one's xy, third one's xy. Right, so I need to do that relative to the ship's position. So this position x, that wants to be 0. So I'm going to start with the top vertex. So that's going to be aligned with the ship's central position. Then we need its position y. So that's going to be upwards minus. Now we need the ship's size, which I forgot to do up here. So I'll call it a radius, even though I'm dealing with a triangle. When we do the collision detection, it'd be great if I could do that this video. When we do collision detection, it's nice to be able to think in terms of radius, meaning the center of the object that you're drawing to its edge. It's nice if you have that value. So the radius will be 20. We'll see how big that is. Then let's calculate the diameter just in case we need it up here. So the diameter equals twice the radius. Done. Right. So we've got our first vertice. First vertice. This radius. Radius. Okay. So second radius. So let's go to the bottom right. So this position x plus. Now it'd be good if we do this relative to the radius. So this radius times, and let's say 0.66, 667, 668, 68 sounds nice. And then it's y, this pos, y, it's going down, and I'm going to say plus its radius, plus its radius, yes, that will do. Right, so we've got two vertices done. Let's do the last one. This position x minus this time, isn't it? Minus this radius times our amazing constant there, 0.68, and this pos y. This will be the same as the previous vertex we drew, which is there. Right, I think I've drawn a triangle. Let's draw our ship. So first we need to instantiate a ship. Let's sorry, my voice. Set up ship. That's not a good enough name. Ships a go-go. That's a much more enthusiastic name for our setup function. For our ship, putting the ship in the space garage. Function, now I've got to remember it, ships go. There we are. Ships a go. So I would like ship to equal a new ship, please. There we go. So that's what I called my ship object, I believe. Yes, ship. And so when we instantiate that ship, it's already going to have its position in the center of the screen. It's got no velocity, nothing like that. We haven't done our input controls, but we should be able to draw the ship. So let's have a similar function to update asteroids. We'll handle all of the ship physics in update ship, as well as drawing the ship as well. So update ship. There's a plane outside. I don't know if you can hear that. Update ship, and all we're going to do is draw the ship first of all. So ship render using its object function. Command save. I'm using brackets here. Command save before running. There we go. And then the live button. Hopefully I haven't broken anything. How many minutes? Oh, I've got a triangle. I've got a triangle in the middle, and it's a little see-through when the asteroids pass, which is nice. Okay, I think you see this. I don't know if you can see that. I don't know if I've recorded down here, but there's like a bug. There's an asteroidy bug. I don't think it's actually a bug. I just think it's asteroids managing to have like a zero velocity on the y, but are just moving essentially left and right. But there we go. It'll be lovely if we can drive through space. Space drive. We could visit anywhere. It's like, this is basically No Man's Sky. We've almost made No Man's Sky. It's, twice as interesting already. Let's get it steering using sine and cosine, or inverse cosine. Right. So input. Let's get input ready. I like to do the input before anything else. So we'll say check input, please, and we're going to refer to some key codes. I think I can just I can't spell function. Function. There we go. Function check input. I think we can say, using P5, if key is down, camel humping. If key is if key is down, and then I believe we can say right arrow, right underscore arrow. I think that's right. So if that's down, we want our ship's theta to increase. I'm going to hard code it here to accomplish something in less than 12 minutes. How many minutes? I think it's been exactly 12. I've got a ship. David 000. I've got a ship. That's not bad in 12 minutes. Or no, that's pretty bad. Ship theta plus equals plus equals. Oh no, I've forgotten basics. Plus equals 0.1. Okay, so we want a very similar thing for the left arrow. We are simply changing the value of the angle. Right, which won't actually do anything yet, because when we draw our ship, we haven't done anything in terms of rotation. So let's do that now. So where's ship render? Screen wrap. Here we are. Sorry, ship render. So what we want to do is, first, before we mess anything up, we want to use push. Not that enthusiastic, lowercase. There we are. Push. And what that will do, will just save the current coordinate system, the current matrix. And then after we've fiddled around, done rotations, translations, and things, then we pop. So that reverts the matrix to the previously saved setting. So we can do anything we want between these, and we won't ruin anything for the rest of the objects, like the asteroids. So what we want to do is rotate. That's P5 function, very simple. Rotate by theta. I think it accepts radians. So again, another P5 function. We can use radians and then this dot theta. Okay. But we also want to translate. Oh, yes, we need to translate to the position of the ship. So we might have to rectify how I drew the triangle. Oh, it was going so well. I knew that was too easy. So translate to this position X, this position Y. So essentially, that means that the center of our world, our 2D space world, is the ship's position. Then we rotate everything relative to that. So the ship only will be rotating, nothing else. But then we're now drawing in terms of the ship's position, which we don't want to be doing. So everywhere we've got this pos x and y needs to be zeroed, because we've already accomplished that with the translation. There we go. Right. I think, yeah, I've called check input, so we might have rotation. Okay, that's very slow. I'm using the right arrow and the left arrow. Let's just increase that value. So I've hard coded it, which means I now have to go and find this function and change it twice, which is a bad idea. Let's just quadruple it. I think that will be fine. So what I'm saying is this rate of rotation or rotation speed ought to be an attribute of the ship itself. It should belong to the ship itself. In fact, it's driving me crazy. Let's do it. And I'm still this whole input function should be handled by the object itself. So we'll call it rot s for rot speed. Rot speed. It sounds like the rate at which something decays, but I mean rotation speed. There we go, minus rotation speed, and let's just give it that speed. We'll place this attribute next to theta. This rot speed equals, and it still wasn't fast enough. Let's just let's just settle on 1 and see how that looks. Oh no, why isn't it not working? Did you see a bug? No. Console reports no bug. What did I do? This rot speed, this rot s equals 1. And in the check input, this rot speed, that's fine. That should be working. My goodness, it's not working. What's going on? Oh! Sorry, this dot. This check input is not an object. It's not a function belonging to the ship object. It has no idea, this function, who this is. Sorry. That must have been a very obvious mistake as you were watching. I apologise it took me so long. There we go. Rot speed. So we're just looking to see how fast that looks. Okay, that's pretty fast. It's still not fast enough. You know what? I'll stop fiddling. But now, at least I can just change this once down here. If I can find it. Rot speed will have, I don't know, just to be safe, 3. Right. We need it moving. Let's get that moving. So we want to make the physics for the ship. So we want to make we want to make a function. I'll call it physics. And so I'm just going to use Euler integration again. In my previous videos, I seem to use this every single time. So we'll have, we need to add the velocity to its position. So this position is a vector, so we can use the add function to add the vectors in the correct way. Add this velocity, and then we want to add the acceleration to the velocity, and then we want to make sure that our acceleration is multiplied by 0. So at the beginning of the loop, we can re-add different forces, and then at the end, everything's equal. Okay, so we've now got some physics for our ship, but we need to be able to move it. So we need thrust. That's exciting. Thrust. Right. Let's make another function then. Space thrust, we'll call it, to make it even more impressive. Space thrust. How am I doing for time? It's about 20 minutes, I think. About 20 minutes, just under. Let's try and go 5 more minutes. See if we can get the ship moving. That'd be great. Ship thrust, space thrust. So this is if we press the up arrow, it will call this function, and hopefully it'll do something. So so we're essentially adding a force, so adding to the acceleration in the forward direction of the ship. So we've got to find out the forward direction using sign. Right. So let's just say this acceleration add. Now we need direction. So that direction is going to be a a vector. So let direction equals create vector, and then want to calculate it. So we can calculate its x component and its y component separately. So let's say directions x equals, so this will be math sine the current angle that we're at, I believe. I can't remember whether math sine accepts radians or degrees, so we'll just throw something in, and then if it looks right, we know we've done it. If not, we'll hack around and see if things work. So I'm going to do the equivalent for the y component, and we've thrown that in. Okay, so I want to add direction. Now, I need to just make sure that the magnitude is not too great. What would it actually... Let's just multiply it. I'm always scared. I'm always scared when I've created a vector that it might be this huge magnitude. So we'll multiply the direction, whatever we found there, by 0.1, just to keep it sensible. So we can now add. So we now can add a thrust to our ship, and in a certain direction. No idea which direction that's going to be. Hopefully we've calculated that okay, but we need to check input for key is down, and now up arrow. And then we just need to call that function, so ship space thrust. There it is. Okay, right. I've got to be careful because if I go off the screen, I haven't screen wrapped the ship. So 3, that's a nice rotation speed. I'm adding thrust. Nothing's happening. Nothing's happening. So either the magnitude is too small or something's going wrong. Can I check? Can I check in the console the ship's theta? No, space thrust. Oh, I know. It might be the Radians issue. Ship space thrust. So we are calling it with the up arrow. I think that's okay. Let's multiply it by 1. Or let's not multiply it at all, and just see if we get any effect. Hello? No. Is my wife coming in? No. Right. Multiply. Right. Let's see if that's moving things. And then I need to just check this function quickly for more obvious bugs. Right. I'm getting no movement whatsoever. So there must be something silly going on. So let direction equals create a vector. So create a new vector. The x component, we're calculating this theta minus cosine, and then we're adding that to that direction vector to the acceleration. We've not called the physics function. Classic. Right. So we're going to return multiplying by 0, 1, just in case. So and let's put the screen wrap onto the ship while we're here. So ship a go-go, update ship. So we draw the ship, then we want the ship's physics to happen. Then we want to screen wrap the ship. So screen wrap, if you remember from the previous video, you can just pass in any object and screen wrap should take care of it. It will check where it is on the screen or off the screen, and then transport the object to the opposite side of the screen, X and Y. Okay, right, here we go. So we can rotate our ship, and look at that beautiful, my beautiful mathematics. Oh, wait a minute, it was kind of working. Screen wrapping. Screen wrapping is interesting. Okay, what seems to be happening is I'm pressing thrust and the ship was moving backwards. So the y component of the ship's movement was wrong. So maybe I didn't have to inverse cosine there. Let's just have a look. And the force wasn't too great. Also, it'd be nice if we had some space friction so that we could slow the ship down. So the velocity, let's just multiply that by less than 1, just to bring it down. And only if the velocity, actually we'll just put that in there, see if that helps. Let's see if we've got our ship going in the right direction now. Nope. Maybe I've got my sine and cosine mixed up. Let's have a look. Let's just swap those around. Oh, it could be an issue of the radian. No, it won't be an issue of the radians. Sine and cosine. I've got to think. No, I've got to invert cosine, surely. Yeah, so now we're definitely. So I'm sorry. I'm pressing forwards. Oh, maybe 0 degrees is heading right. So we kind of want, because we're at minus 90 degrees. Oh, I don't. Right, let's hack. Let's just hack around until it works. Oh, that's terrible. Okay, that's quite good. Oh my goodness. Oh dear. No, these are definitely wrong here. This needs to be sine. This needs to be cosine. And next thing I can try is simply to so I think I've got the coordinates kind of right. So I'm pressing thrust and we're going backwards. I'm pressing thrust and we're going backwards. Oh, because upwards is minus a minus number. Can I simply minus a vector? A vector? I don't know. No, it doesn't like that. It doesn't like that at all. That did nothing. Oh God, what do we need to do? Oh no. No, that's not right. I can't minus the angle. Oh no. No. This theta. We need to multiply. Oh, no. Yes. Yes. Can we multiply it in the correct way by a minus number? No. Actually, this is going in radically different directions according to what I'm pressing. So maybe the issue is Maybe the issue is that I'm passing degrees in here instead of radians. Let's try that out. Well, we are rotating, yeah, we are rotating the ship in terms of radians. So I assume we ought to be working in the same units. Although, at this point, I've abandoned what I thought I knew. So now that crashes. That crashes. Radian is not defined, so that's a simple typo. Let's try that again. Ah, that seems to be behaving almost correctly. So that's minus. Let's go back to the original configuration with radians this time instead of degrees. So maybe the maths was okay. Yes, okay. So after all that fiddling and fine tuning and hacking around, the maths was fine, but we were using the wrong units. So we've got our ship moving around. I think we can afford to up this a little bit. So just normalizing the vector and multiplying it by 1. And yes, our ship now moves quite fast. Doesn't slide as much as it does in the original game, but I quite like this. It's more like space driving. So let's just see if screen wrap works. Yes. And on the y-axis, wonderful. So now we can drive around space. I've noticed that the asteroids are definitely, there's something buggy definitely happening with the asteroids. They get trapped down there, so there is something wrong with space, the screen wrap. We have got a ship moving. So, I'm gonna probably upload this one, even though we had loads of bugs with the radians degrees issue, but that might be helpful for someone who might have a similar issue. There we go. Hope you enjoyed. Thank you very much.